Hey there, science enthusiasts! Today, I'm diving into a math problem that didn't just solve an equation, it revolutionized physics forever. Ready to get mind blown? Let's go! So picture this, it's the early 20th century. Physicists are scratching their heads over a major puzzle. Classical physics, the laws that governed our understanding of the universe, are failing at the atomic level. Enter Max Planck, a brilliant German physicist who's about to flip the script. Planck was wrestling with something called blackbody radiation. Simply put, it's how objects emit light and heat. Classical theories predicted that at higher frequencies, objects would emit infinite energy. Sounds crazy, right? It's what we call the ultraviolet catastrophe. Now, Planck didn't set out to upend physics. He was just trying to fix this one problem. But to do that, he had to think outside the box, way outside. He proposed that energy isn't continuous. Instead, it comes in discrete packets called quanta. This idea was radical. It contradicted everything physicists believed at the time. And guess what? It worked. Planck's quantum hypothesis solved the ultraviolet catastrophe. But the implications were far bigger than anyone imagined. Planck's work laid the foundation for quantum mechanics, a whole new branch of physics. It's like discovering a new continent. Quantum mechanics opened the door to understanding the weird, wonderful world of atoms and particles. It explained phenomena that classical physics couldn't. And it paved the way for groundbreaking technologies, lasers, transistors, even the computers and smartphones we use every day. All thanks to one math problem. But that's not all. Planck's discovery also sparked a revolution in how we understand the universe itself. Albert Einstein expanded Planck's idea to explain the photoelectric effect, proving that light itself is made of particles called photons. Niels Bohr used it to unlock the secrets of the atom, and Erwin Schrödinger transformed it into quantum wave mechanics. And it set the stage for the development of the atomic bomb, changing the course of history. What began as a fix for blackbody radiation became the foundation of quantum mechanics, the science of the very small. It explained why atoms exist, how stars shine, and how lasers work. The quantum revolution was unstoppable. His curiosity and out-of-the-box thinking didn't just solve an equation, they changed the world. Today, Planck's equation powers technologies we use every day. From semiconductors to GPS, quantum mechanics touches every corner of modern life. Without it, there would be no lasers, transistors, or internet. Planck's math problem didn't just revolutionize physics, it redefined reality itself. It taught us that the universe isn't as smooth and predictable as it seems. Beneath the surface lies a world of probabilities, particles, and waves, strange yet beautiful. The next time you look at your phone, turn on a light, or stare at the stars, remember, it all started with one math problem, one constant, and one man who dared to think differently. The quantum revolution is far from over. What will the next breakthrough be? Thanks for joining me on this journey through the quantum realm. If you enjoyed this video, hit that like button, share it with your fellow science enthusiasts, and remember to subscribe to ENITECH for more mind-blowing content. Curious about how math shapes our world? Subscribe to ENITECH for more stories connecting science, technology, and everyday life. Until next time, stay curious.